This is a basic concept in geometry, parallel and perpendicular lines. I'm going to try to simplify the concept to make it easier to understand. Now I have 3 lines drawn here. Each will be a different type of example. The first one will be the first line, and then I'm going to draw a second line that is going to be steeper than the first line. When I say steeper, I mean going back to an algebraic concept, y equals mx plus b. This is the standard, the slope-intercept form of equations. These equations make these lines, and the m part of this slope-intercept form is the slope. So whatever the slope is will determine the steepness of the line. Now let's say this one is y equals 2x plus 1, and let's say this is y equals 4x. So you can see the slopes are different. This is 2, this is 4. This 4 is bigger than 2, it's going to be steeper. Now the thing is, because this is steeper, eventually the 2 lines, if I project them out, will intersect at one point. That means they are not parallel. Second example. Let's draw a line that's flatter than the first line. Now let's use the same equation, y equals 2x plus 1, but for the next line I'm going to use the slope. Well, it's flatter, so it's going to be less than 2. Let's use the slope y equals 1/2 x. Now these slopes are different, 2 and 1/2. 1/2 is less than 2. It's going to be a flatter line here. Now if that's the case, eventually, if I project the lines out, the flatter line will intersect with the original line at some point. So these can't be parallel. Now let's use a third example. Let's keep up with the y equals 2x plus 1 equation, and the line I draw next to it. Let me try to straighten this out. Let's say this is y equals 2x. Now the two slopes are the same, 2 and 2. That means this second line is neither flatter nor steeper than the first line. So if I were to project the 2 lines out, because they are the same slope, they will never cross up here, nor will they ever cross down here. They are parallel. And what makes them parallel, looking at the math, is the slope. They both have a slope of 2. So that means they are the same slope, and the lines they make will be parallel. What if we have 2 lines that have a slope that is a fraction? For example, the slope here is 1/4, the slope here is 1/4. And what if their y-intercepts, here is plus 2, here it's or here it's positive 2, here is negative 1. That doesn't really matter. As long as the slopes are the same, 1/4 and 1/4, they will make parallel lines. What if the 2 slopes are negative? Y equals negative 3x plus 4, y equals negative 3x plus 1. The 2 equations, they have the same slope, but they're both negative. Because they're negative, that's why the orientation of the lines is going to look this way, going this way as opposed to going that way. Well, in any case, the 2 slopes are the same. Because they're the same slope, these 2 lines will be parallel. The negative slope does not matter. They're both still parallel. Moving on to perpendicular lines. Now, perpendicular lines are more than just 2 lines intersecting. Let's say this is y equals 2x, and this one is y equals 4x. Now, going back to what we talked about with parallel lines, if they didn't have the same slope, that means the two lines will eventually intersect somewhere. This second line with the slope of 4 is steeper than the first line with a slope of 2. So they're going to intersect. Let's say this is where they intersect. Now the thing is, they're not going to be perpendicular just because they intersect. There has to be more to it. That means you have to take a closer look at the slopes. Let's just hold off on this, go to the next, and let's say this is y equals 4x, and this other line is y equals negative 4x. Now, the slopes here are not the same. One is negative 4, the other is 4. That means the two lines will eventually intersect somewhere. Now, the steepness of the lines is going to be very similar because they're both 4. However, because one is negative, it's not going to be going in the same direction. It's going to be going the other direction. So they will intersect, but the steepness is very same. The thing is, it's not going to be perpendicular because it won't make these 90-degree angles around here. Now the third thing to look at, third example here, two lines, let's say they intersect. Let's say they form a 90-degree angle right here, which by extension will also be here, here, and here. So 90-degree angles all around. Those are perpendicular lines. Two lines intersecting and they form 90-degree angles. Now, there has to be something special about these perpendicular lines. It's particularly something special with their slopes. Now, if we start off with here, the basic, let's say this is like an introduction to going to perpendicular lines. The two slopes are opposite. One is positive 4, the other is negative 4. But they are the same steepness. Now imagine let's say one line is steep, and then let's say they're opposites. So imagine this is a mirror, and then this is they're opposites of each other. Now if I were to lay them one on top of the other, if you can visualize it really well, they're not going to make 90-degree angles. No, that's not going to happen. In this third example here, in which 90-degree angles are made by the two intersecting lines, the two lines have to be angled at a certain way to make this all happen. And to do that, the slopes first not only have to be opposite. So let's say this one is positive, and let's use 4 again, and then this one is negative, but they have to be reciprocals of each other. That is the only way that the two lines can be angled just right so that they make these 90-degree angles. So let's say this one is y equals 4. This one will not only have to be negative, but it will have to be the reciprocal. So take 4, and let's put it over 1. Let's make it a fraction. 4 over 1 is the same as 4. The reciprocal of 4 over 1 is, flip it, 1/4, or 1 over 4. So this one over here is not negative 4, it's negative 1 over 4. These two lines have opposite reciprocal slopes. Some use the terminology negative reciprocal. I just like using opposites because I know positive and negative are opposites. Conceptually, that is. It may not be the precise mathematical term, but I just like to think of it that way, opposites. And the reciprocal part, so take 4 over 1, and flip it, and it becomes 1 over 4. That's where I get this 1 over 4. So these two lines, y equals 4, let's put the x, and y equals negative 1 over 4x, they will intersect and create 90-degree angles. Hence, they are perpendicular. Another example of perpendicular lines. Let's say this line is y equals 3x. This line will have the opposite reciprocal slope. That means it will be negative, and the reciprocal of 3 is 1 over 3. Y equals 3x, y equals negative 1 over 3x. They are perpendicular lines. Another example. Let's say this line is y equals 1 over 4x. The perpendicular line over here will be the opposite reciprocal of 1 over 4. Opposite will be negative, then reciprocal, take 1 over 4, flip it, and it becomes 4 over 1. But you don't have to write 4 over 1, just write 4. Another example. Let's say this is y equals negative 3 over 2x. The perpendicular line will be, take the opposite, so it's going to be positive. Then the reciprocal, take 3 over 2 and flip it, and it becomes 2 over 3. Y equals negative 3 over 2x is perpendicular to y equals 2 over 3x. Okay, now I didn't talk too much about the y-intercepts because in parallel and perpendicular lines, the important points to focus on is the slopes. Same slope, parallel lines. Now, the y-intercepts are different here. This is plus 4 and this is plus 2. So this equation over here will be higher than this one. It would be located higher on the coordinate plane. But since they are the same slope, they will never intersect. They'll be parallel. Now, let's say they were the same y-intercept. So let's say they were both y equals 3x plus 4. Now, if that's the case, that means they are the exact same line. They will actually be one on top of the other. And that can't be parallel. That's just two lines, one on top of the other. They're the same line. So that's why for parallel lines, the y-intercepts have to be different. So that the two lines will be separate from each other. They won't be one on top of the other. And they will obviously be parallel if they're the same slope. Now for perpendicular lines, let's say they are the same y-intercept. They both cross at 0, 1 in this example. That doesn't matter because as long as these slopes, 1/2 and negative 2, are opposite reciprocals, they will make 90-degree angles. It doesn't matter if, let's say this is the y-axis right here. If the two lines cross at the same point on the y-axis, they have the same y-intercept, it's not going to matter. They're still going to be perpendicular. They intersect and they make 90-degree angles. It's not going to matter. If they have different y-intercepts, let's say I moved this line here down here. The y-intercept dropped a little bit. Let's say this is 0, negative 2, or something like that. It's still going to be perpendicular. They still intersect and make 90-degree angles, as long as the slopes are opposite reciprocal.